Okay, welcome back. Now we're ready to create dasher.cpp, which is going to require a bit of setup code to create our window and our while loop and all of that good stuff. And since this is stuff that you've done before in our previous sections, I'm going to give this to you as a challenge right off the bat. So your challenge is to create the basic code for dasher.cpp. This means you need to include the raylib header file so we can have access to raylib. You also need a main function. And inside the main function, we're going to need to create some window dimensions for init window. So create a couple of integer variables for the window width and the window height. Go ahead and call init window and pass those in, as well as selecting text for the window's title bar. You're going to need the while loop, which means you need to call setTargetFPS just outside the while loop. Let's go ahead and initialize the frame rate to 60 with this function. Inside the while loop, we'll need our begin drawing function, our clear background, go ahead and pass white into that, and end drawing. Go ahead and pause the video now and work on this. Now, it's okay if you need to go and look at the source files for our previous projects if you need to get a little bit of a reminder of how these things look, but create this basic setup and then we'll go through this together. Okay, so we're here in dasher.cpp and we're ready to start coding. So I'm going to first include raylib. So I'm going to use the include directive and include raylib.h. And next thing we need is the main function. So we're going to say int main, and here's the main function body. Now we're going to need those two integer variables for the window width and the window height. So I'm going to say int window width, and I'll use braced initialization, and I'm going to use a value of 512, so 512 pixels. Now for the integer for window height. So I'm going to call this window height, and I'm going to initialize this with a value of 380. That's okay if you used different numbers for your window dimensions. Now I'm going to give this a comment and say window dimensions, and I'm going to introduce you to a new concept known as constant variables. There's a keyword for designating a variable to be constant, and that keyword is const. Now, when we declare a const variable, we're saying that we are never going to change this variable's value for the duration of the program. For this reason, const variables have to be initialized immediately. And if you attempt to change this variable later on in the program, you'll get a compilation error. So down here, if I say window width plus equals 1, this will not compile, and I'll get a squiggly red line, and hovering over it, it says expression must be a modifiable L value. This is compiler speak for you cannot change this variable. It's not modifiable, it's const. Making a variable const is a great idea if you never plan on changing its value throughout the lifetime of the program. For one, attempting to change variables that should never be changed is an error, and so compilation errors will prevent you from even running the program, so you'll be forced to fix it. And also, if all the variables that shouldn't be changed are marked const, then you know that you'll never have to keep track of what they changed to, because they'll always be the value that you initially gave them. Let's make window height also const. And from now on, if we're creating a variable that we don't plan on changing, we're going to mark it as const. And when all of your variables in your program that should never change are marked const, it's said that your program is const correct. And that is good programming practice. Next, we're going to initialize the window with init window. Init window takes a width. We're going to use window width. Next is window height. And finally, we have the title for the title bar. And we're going to use the title Dapper Dasher with an exclamation point. Why not? Now, let's give this a comment and say initialize the window. Next, we need to set target FPS to 60. And we have our while loop after that. Now, up until this point, we've been using window should close, calling that function and comparing it with the value false. So if window should close is true, then this expression is equivalent to true is equal to false, which is a false expression. Now I'm going to show you a shorthand for this. Let's just delete this double equals false part, and just at the beginning of window should close, I'm going to use an exclamation point. This is known as the negation operator. It takes whatever value it's attached to and negates its truth value. So if window should close returns true, the negation operator will flip that and return false. So if we hit the X button or we hit the escape key, window should close will return true, the negation operator will flip it to false, and this while loop will exit. So this is the same as saying window should close is equal to false. Next, we're going to begin drawing. So let's call begin drawing. And I'm going to comment this and say start drawing. Just after begin drawing, we need to clear background. And I'm going to pass in white. And finally, at the end, we need to end drawing. And this gets a comment as well, and we'll say stop drawing. Okay, so we've set this up, and if we hit run and start debugging, we will get our window. So here is our window. Now we can hit the X to close it. And before we conclude our video, I'm going to show you one more new thing, and that is Raylib's close window. You see, up until this point, whenever we wanted to close the window, we just break out of the while loop and the main function reaches its end, so the program terminates. But if you want to do things technically the correct way, Raylib has a close window function that takes care of actually shutting down the window properly before our program terminates. So this function contains some under-the-hood functionality that closes the window. So we're going to do things the right way and call close window at the end of our programs where we have a window open. Okay, so in summary, we've created a Raylib window, which is nothing new. We've done that in our previous projects. Only this time, I've introduced you to a new concept called const. And we learned that const variables cannot be changed throughout the duration of the program, and that if we don't plan on changing a variable, it's typically considered const correctness if we mark it as const, and that way we'll get a compiler error if we attempt to change it illegally. We also learned about the negation operator, and placing the negation operator at the beginning of something will negate its truth value. And we use this with window should close. So when window should close returns true, the negation operator will flip that to false and return false instead. Likewise, when window should close returns false, the negation operator will flip it to true and return true instead. So we're using this now instead of using window should close double equals false. The two techniques do the same thing, but now you have an additional operator in your toolbox. So now we have a Raylib window set up, and we're ready to continue creating this game. We'll do so in the next video. See you then.